Okay, so how about um, for our currents? Okay, so we are to determine the currents in our each of the resistances. Like we said, we are to solve only for the I sub t or I sub 1 and I sub 2, which as you can see, the I sub t is the total current. So using the Ohm's law class, okay, Ohm's law states that current is simply voltage over resistance. Okay, so since you are trying to solve for the total, so we can just use IT is using voltage total over your total resistance, which is earlier we have solved already for the total resistance here, which is 7.5, and your total voltage is the one that is our source, which in our given is 30 volts. So therefore from there we'll be able to solve for the total current, which is 30 volts over your total resistance, which is 7.5 ohms. So using your calculator class, so 30 divided 7.5, we have 4. You see? So that is 4 amperes. So that is again our answer for letter B. One of the answers only. Now, how about for our the current through the I sub or the current through 5 ohms? So the same current that is flowing in your resistor 5 ohms. So 5 ohm, so the current is still 4 amperes. Okay, it's because like I have said, they are the same path, so the current flowing are just the same. Now how about for the I sub 1? How are we going to determine the current in there? Now take note class that in a as you can see, it's parallel. Okay, they are parallel, so that means that they have different currents in there, unlike in the series that we have the same current flowing. In this case, I sub 1 and I sub 2 are different in values. It's because, and they are not the same as I sub t, because 7 and 3 are in parallel. Okay, so how are we going to solve for that? So this is how we will do it. Okay, so we have to determine first the voltage at this point here. Okay, because the voltage here will be used in order to solve for I sub 1, because as you can see here class, can I erase this one? As you can see here in our figure, okay, I will erase this class. Okay, we are trying to solve for I sub 1. So using our Ohm's law, so I sub 1 is simply V sub 1 all over R sub 1. So in this case, our R sub 1 is represented as 7 ohms. Okay, let us assume that that's our R sub 1. Okay, so since we have your R sub 1 already, or the 7 ohms, so we need to know the voltage across that resistor. Okay, we have to know that. And how are we going to know that? So since we have here a supply of 30 volts, but class, remember that 30 volts is just here within the battery. Take note that we have the 0.4 ohms and we also have 5 ohms in series. Now, can you recall what's our principle when it comes to series? In series, what happens to the voltage is nagkakaroon tayo ng voltage drop. Okay, there's voltage drop. So that means that this 30 volts, okay, will be decreased whenever it supplies resistances in series. So that means that this 30 volts can be dropped here at 5 ohms, and some of it will also drop here at 0.4 ohms. Now, how are we going to determine the voltage drop in each resistances? If you could recall in Ohm's law, okay, voltage drop is simply I times R. Can you recall that? Which means that if you want to know the voltage dropped in that resistor, so all you have to do is multiply the current flowing in there times the resistance of that resistor. So in this case, if you want to know the voltage drop of 5 ohms, okay, so simply multiply the current flowing in there times the 5 ohms. So earlier, we have said that the current flowing in 5 ohms is I sub t, which is 4 amperes, right? So Therefore, voltage at 5 ohms, or voltage drop, let's say voltage drop at 5 ohms. So, since the current is 4 amperes, okay, and the resistance is 5 ohms. So, that means, how much is this? This is 4 times 5 is 20 volts. So, that means, within the 5 ohms itself, so 20 volts of the 30 has gone to it. Which means, ilan na natira? So, meron pa tayong 10 volts. But take note, meron pa tayong 0.4 dito, class. Okay? We have still 0.4 ohms here, which means na meron pang voltage drop na mangyayari. Okay? So, ilan yung voltage drop kay 0.4 ohms? So, the same formula. So, I times R. In this case, the same 4 amperes times 0.4 ohms. So, ilan yung napunta kay 0.4 ohms? So, 4 times 0.4, we have 1.6. So, 1.6 volts. So, imagine, 20 volts, and 1.6 volts yung napunta agad sa dalawang ito. So, which means, ilan na lang yung natira dito sa point na to? Ilan na lang yung masusupply sa dalawang resistances in parallel. So, in order for us, class, to determine that, so we will subtract. Okay, we will subtract. So, can I erase this, class? We'll erase this first. Okay, I will erase this. There. So, that means that the voltage, let's say, at point V sub 1. So, V sub 1. So, in order for us to determine V sub 1, so we will simply subtract your V sub t. Okay? Subtract here the voltage drop in 5, which is the 20, minus the voltage drop at 0.4, which is 1.6 volts. Can you follow? So, from that, 30 minus 20 minus 1.6 volts, and that is how much? So, 30 minus 20 minus 1.6, so that is 8.4. So, imagine, class, only 8.4 volts is supplied here in the 7 ohms. Okay? But that's not the answer that we're looking for. What we're looking for is the current flowing here in the 7 ohms. So, to solve that, we will be using this formula here. Okay? So, like you said, since the voltage supplying here at 7 ohms is 8.4, so therefore, using the Ohm's law, we have 8.4 volts all over your R sub 1, or in this case, our 7 ohms. So, we will subtract, or we will substitute here. So, I sub 1 is simply how much? So, 8.4 over 7, that is how much? This is 1.2. Okay? So, we have 1.2. And what is the unit? That is, of course, amperes. Okay? 1.2 amperes. Now, this is another answer, class. It's because earlier, we have the I sub t already. The I sub 1, this is answer. So, we still need the I sub 2, which is the current flowing in your resistor 2, or in this case, our 3 ohms. Okay? Now, how are we going to solve that? So, the same here, class, in your Ohm's law. So, let us use the Ohm's law to solve for the current. Let's say I sub 2 is V sub 2 over R sub 2. Again, class, your R sub 2 here is represented by 3 ohms, or we have represented R sub 2 for 3 ohms. Okay? So, now the question, what is the voltage across these 3 ohms? Now, if you can observe, 7 and 3 ohms are in parallel. If you could recall in our principle, the voltages in a parallel connected components are equal, which means whatever the voltage here in your 7 ohms, that is also the voltage here at the 3 ohms, which means at this one, V sub 2, it is just equal with your V sub 1, which is your 8.4 volts. You follow? So, using this value, class, so 8.4 volts divided by your resistor, which is 3 ohms. Okay, how much is that? So, I sub 2 is So 8.4 divide 3. There. We have 2.8. Okay, so we have 2.8 and the unit is amperes. Look at that, class. 2.8 amperes. So that is already our answers, class. So earlier, I sub t, I sub 1, I sub 2. Okay, so again, those are the three currents in each resistors. Okay, this I sub t is the current flowing in 5 ohms and 0.4 ohms. This I sub 1 is the current flowing in 7 ohms, and this I sub 2 is the current flowing in 3 ohms. Now, how are you going to know if your answers are correct? How are you going to check it? Okay, so if you could recall, in a parallel, okay, as you can see, here's a junction. Okay, so as you can see, there's a parallel, and in a parallel connection, the current are additive, which means the total current is the sum of each of the currents there. So as you can see here at this point, okay, this is I sub t. So as you can see, the current is divided into I sub 1 and I sub 2, which is the sum. Okay, so let us check if it is equal or they are the same. Okay, so it must equal. The sum of I sub 1 and I sub 2 should equal the total current to make it sure that it is correct. Okay, so our I sub t is 4 amperes. Your I sub 1 is 1.2. And your I sub 2 is 2.8. Okay, let us check. They should be equal. If not, that means your solution is wrong. See? The answer is still 4 amperes. So what does this indicate, class? That means that these values are correct and it's our solution is right also. So again, for R sub t, the answer is 7.5. Yeah, 7.5. And for the I sub t, this one, I sub 2 are 1.2, and I sub 2 is, I sub 1 and I sub 2 is 2.8. Okay, and that's it. For the solution for example number 14.